So in this tutorial we are going to look how to install Kali Linux in Azure Container Instance in 3 different ways. So let's get started. First of all, we are going to navigate and log in into the portal.azure.com, where we are going to search for container instances. From this page we can go ahead and start the creation of Azure Container Instance by clicking on the Create button or through the Create Container Instances button. From now on, we will be prompted to enter a couple of basic information about the container instance. So first of all, we'll select the subscription. In case you have multiple subscription, you need to select the appropriate one, which will be charged. Then we are going to choose a resource group. So a resource group generally is grouping of the resources within the Azure. This is helpful for troubleshooting, for review of the deployed instances. You can charge specific department more or less. So this is useful for billing purposes. So you can choose one of the existing resource groups, or if you don't have any, just go ahead and create a new one. This will be helpful also for the life cycle of the deployed resources as well. So now, after defining resource group, we can specify the container name. So in this case, it will be Kali Linux 001. I'm based in Europe, so I will choose one of the regions within the Europe. And then I need to elect image source. So it can be the quick start images, Azure Container Registry, or other registry. Yeah, so one of those 3 options. It can be private. Each resource could be public or private. In today's tutorial, we're going to use public resource, but let me explain what each option actually means. So quick image is basically Microsoft public image, and it includes multiple other public images that has been prepared by Microsoft. But we can also bring our own containers, container images as well, either through Azure Container Registry or other registry. So basically, if we use the private Azure Container Registry, this is Microsoft Registry. You can think of it as a container repository or container image central repository. And if we use it for deployment of container instances within the Azure, the deployment will be faster than pulling it from some other public or private registries. In this tutorial, I'm going to select other registry that will be public. By default, the image name that I will enter here will be pulled from Docker Hub repository website. And that's why we are going to navigate to this website and search for official Kali Linux Docker image. So the official Kali Linux image is Kali Linux Kali rolling, and using the tags I'm going to find out the appropriate architecture for deployment of container instances in Azure, which is AMD64. So I copy this image name and paste it to Azure. I will delete Docker pool because I'm not going to obtain it to my local machine, but instead I will deploy it within the Azure. Then I can select operating system type, Linux or Windows. Obviously this is Linux. And then I can choose the size, where I define the size of memory and vCPUs. So basically, choosing this size, I'm choosing the right computer resources, which basically says how powerful machine or this instance should be. For purpose of this demo, I'm choosing the default settings. Then I'm going and specify the networking settings. So here I can select, for example, DNS name or label. So basically this is DNS name that will be used to access, for example, web-based or other application that is running on our container instance. And the access will be through this custom label plus Azure region and Azure container.io domain. And then I can specify ports. By default, there is port 80. If I want to access the web application that is running on the container instance, I can specify for free if the web instance is encrypted. But in this case, I would like to access the container instance through port 80 and port 22, so I can remotely SSH to the Kali Linux shell remotely. Then I have option to specify advanced settings, and here we will pay attention because with default settings, which was restart policy on failure and keeping everything else like environment variables or command override default settings, my container Kali Linux machine instance has been constantly restarting, so I couldn't log into the shell and I didn't know what's going on. So I used application that is called Speechify. Speechify is basically mobile application, but you can also use it on the computer. So for example, as a web browsing extension. For example, I have it installed on my Chrome browser. And basically this application is simply text-to-speech reader with that is powerful of reading text from multiple languages and with different narrator voices based on your choice. I'm showing it to you because this is how I find actually root cause why Kali Azure container instance is not booting up, because this application speed up my research because I can run through a lot of text in short period of time because I can adjust the text speed, text reading speed as well, and without need to focus with my eyes, on every single sentence. So I can just run through it and listen to the text until I find the information that I needed. So here is quick preview. I really like this application. I'm using it for 2 years by now. And so this is my second year of usage. And that's why I'm showcasing it to you. So in case it will be useful, you have the link down below in the description. But let me use this application to read out the outcome of the configuration settings that we need to apply to our Azure Kali Linux Azure container instance that we are creating, so that we can prevent it from restarting or crashing basically.
Container continually exits and restarts, no long-running process. Container groups default to a restart policy of always, so containers in the container group always restart after they run to completion. You may need to change this to on failure or never if you intend to run task-based containers. If you specify on failure and still see continual restarts, there might be an issue with the application or script executed in your container. When running container groups without long-running processes, you may see repeated exits and restarts with images such as Ubuntu or Alpine. Connecting via exec will not work as the container has no process keeping it alive. To resolve this problem, include a start command like the following with your container group deployment to keep the container running.
So now that we know that the machine has been crashing due to the fact that the instance didn't have long-running process running, so that's why we are going to configure command override. Command override is basically, in other words, startup script. So we are going to use the exactly same startup script as from the Azure web page example, which is tel-f dev-null, which will be basically trying to pull kind of like logs from non-existent location from dev-null, but it will keep running continuously upon the start of the container. Then we can specify additionally environment variables. So if you have application that requires binaries from specific location that is not default binary path, you can specify it here, or anything else that is custom required for applications. Anyway, after this, you can specify the tags for the deployment. So tags, in this case, I'm leaving the default, which is none, but here you should ideally put some identifier name, which can be like your full name, or email, role, group where the person belongs within the organization. And basically this tag is allowing you to do reports on how many resources each person for your Azure subscription has deployed, so you can charge them more or less, or so on. Now we will review simply the configured basic settings of our Azure Container instance. If we are satisfied with configure options, let's hit the Create button. This will take a short period of the time until your Docker container basically starts. For me, it took sometimes it happens within a couple of seconds or up to 2 minutes, more or less. It always depends on the image that you are using. And upon the deployment, we need to check the status of the instance. So this should be in the running state. And you can check in overview section your fully qualified domain name and IP address. And basically this confirms that the Kali Linux container image or instance is actually running successfully. And we can now connect to it through the web UI shell. So under the connect, we are going to use the bin bash shell. We can increase the font size of the shell. And let's configure this machine so we can remotely connect to it. So first of all, before we install any software, we're going to download the latest software repository so that we can install up-to-date software basically. And we are going to install the OpenSSH server, which is free open source SSH daemon server, and Apache 2, which is well-known HTTP web server. We'll wait for the installation to finish. Speed this up. Now, after installing basically the web server, we can try to access it through the FQDN or IP address assigned to the container instance to make sure that the install web service is up and running. And through the shell, we need to make sure that service is actually started upon the installation. And you see initially the access to the web server was not running until we started manually the service, and now we could display the default Apache 2 web server site. Now what we're going to do is to display basically the confirmation that we have indeed installed Kali Linux. And I did it, for example, we can do it multiple ways, but for example, for cat etc issue command, we can confirm that Kali Linux is up and running. And basically, etc issue file is used to display banner for local users before the login prompt actually happen when they're trying to log into the machine. But this file also includes typically operating system, architecture identifier, release number of kernel, and so on and so forth. So yeah, I'm just using it to display that we have and we are logging to Kali Linux machine. Now what we are going to do, we are going to start also SSH service so that we can successful SSH to the server. But before that, we need to do some customization. So I'm also installing the Vim, which is text-based editor. And then I'm going to edit SSHD config. So basically, I'm going to find a line which is permit root login, and I will set it to yes value. So which will basically enable root logging over SSH. This is not the best security, but just for demonstration purposes, I'm enabling root logging for SSH authentication. I'm going to quit the Vim editor. I need to restart the SSH service, so the changes that we made to the SSH daemon will take effect. And now I can remotely connect to the Kali Linux Azure container instance. And you see that it works like a charm. And this concludes the first section of our today's tutorial on how to install Kali Linux in Azure Container Instance using the web UI. So here is just a quick summary. So we went to the portal of Azure. Then we created the container instance with following settings. Just important is that we specify Kali Linux image from Docker Hub in AMD 64 architecture. Then we set up the networking services, open our ports for this container, and we set up the restart policy and startup scripts so that the instance will not continuously restart. And actually for this demonstration purpose, I'm using for Lucid Chart and Lucid Spark. So if you are also interested in trying this application, you can follow the links down below in the description. And basically this was everything that was required to have up and running Kali Linux instance in Azure Container. So now in this section, we are going to look how to deploy the Kali Linux instance from Kali Linux official image from the Docker Hub site in the Microsoft Azure. And we are going to speed up the deployment by using single one-liner command. So which will do the deployment very fast comparing to the web UI that we just covered. So let's get started. Let's navigate to the Cloud Shell in Azure portal website. Let's open it into the full screen. And in order to create the Azure Container Instance, we will use az container command, then create argument, and then we are going to specify the resource group with G parameter and provide the resource group name. Then we will specify the name of the container instance by using this --name attribute. So this is our second Kali Linux instance, so we call it Kali Linux 002. Then we are going to specify by --image the name of the source image from where our Azure Container Instance will run from. And by default, we are not specifying any remote repository. By default, the Docker Hub will be leveraged. So we just specify the proper name of the Kali Linux image and its architecture. Then we can specify the startup command as we did before, which will be through command line. And we are going to specify the long-running process del-f/dev/null. Then we are going to specify location. So basically, this is the region from where the container instance will eventually run. And then we are going to specify DNS name label. So this will be used as prefix for a fully qualified domain. So this is our custom DNS name, which will be suffixed with the default Azure domain through which the container instance will be reachable. Then we are going to define ports over which the container instance is going to be reachable. So ports 20 and 80, and dash out table will just format the output of the creation of the Azure container instance so that it's more readable. And upon a couple of seconds, you see that the image container instance has been created. We can see which public IP address it has been assigned with, what are the CPU memory resources, and whether it is in a running state so it does not keep crashing, right? And using Web UI, the new container instance indeed has been created, and this process took just a couple of seconds as we write the command, one-liner, for the provisioning, and we can access it through the CLI over here as well. But you see, like, you can potentially automate the deployment of the container instances to make it really fast. So as a summary, again, I'm going to use the Lucid Spark and Lucid chart to go through the overview how we install Azure container instance through the CLI. So we navigate through the Cloud Shell, right? And we specify our command. Here I'm showcasing you the link that you can access in order to get overview of further CLI like attributes. Well, when you want to deploy the container instance, maybe you would like to make further customization, so you can refer to official Microsoft source. And you see, like, deployment of the Azure container instance through the CLI is very straightforward and fast. So now we are moving to the next section where we are going to create Kali Linux Docker instance in Azure from custom build Kali Linux image that we will create on our local PC and then upload it to Azure Container Registry, so to the Azure repository. And then we are going to install our customized Kali Linux image from this Azure Container local repository. So let's create a container registry in Azure UI. So we can search for container registries, click create button. And we need to fill in a couple of basic information such as subscription, resource group, and registry name. So this is important because we are going to use this as a login server name when we'll be uploading our custom Kali Docker image to Azure. So you see our registry name got suffix with .azure.cr, which stands for Azure Container Registry.io domain. Then we can specify a location where this registry will be basically located, where our images will be stored. And we are not going to change SQ because we don't want to change scalability options. We can go to the next settings. And you see we don't have control now over the networking configuration, so this will be public container registry. We can complete additional information about the encryption, that I'm keeping this default, keeping default tags, and then I can just review the information filled in. If I'm satisfied, I just click create button, and container registry will be created within a few seconds. And upon the creation of this container registry, I will see the information such as login server, so our fully qualified domain name. And under access keys, I will enable admin user because this will create the credentials that can be used in order to log into Azure Container Registry remotely and upload our own container images. So in this case, we are going to upload our Kali Linux image. The username will be same as the name of the container registry, and password will be auto-generated. So you can copy paste this information like login server, username, password, text file. We're going to refer to it later or come back to this website when we'll use it. And you see when I go to this under services, there is a repositories section, and you see currently it's empty. So basically we have created empty Azure Container Registry for Docker images. So now we're going to move to our local computer and we'll create file called Docker file. I have this already prepared, but let me walk you through, because from this file we are going to create customized Kali Linux Docker image. So we're going to use the directive from. Basically from directive specify that I want to build a custom image that uses Kali Linux, which is existing image from Docker Hub repository. And basically I'm saying here, like, let's grab the latest version of this Kali Linux image. And since we didn't specify the registry or like login server details, by default, we will use the hub.docker.com source to locate this source image. And I will use the AMD64 architecture because this is what I will need in order to deploy the image in Azure from Azure Container Registry later. So then next I have the directive called maintainer, which can be basically username, full name, email address, like basically contact person who created this Docker file or is maintaining it, right, for their updates. Then we have run directives, and over here I have commands such as like updating software package repositories in order to install the latest version of SSH server, latest version of the tools such as like Vim text editor, curl, sudo, nettools, and so on. Then I have run directives that also set the root password or change it, right, to whatever I want. And I'm creating also the regular user called Kali. I'm giving him sudo, like admin privileges, and I'm setting the password. So here I'm using your secret password for Kali user. Obviously put something, like something more secure that hackers cannot guess. But it's for demonstration purposes only, and I'm going to destroy this instance upon this demo. But basically, the run command is used when we build the Docker image from Docker file. It runs only once when we build the image. So this will be like installing some or doing changes to the operating system on top of the base Kali Linux image that we downloaded from Docker website, Docker Hub website. And on the other hand, we have also command cmd, which execute, in my case, the start ssh.sh script, and then goes into the bash shell. But basically, cmd directive execute every time the container starts. So when it will be restarted, I will make sure that the script or command that I'm calling here with cmd directive runs every time the container restarts, so not only once when we are building the image. So this will make sure that, for example, I have a long-running process always running, right, on that container when it restarts due to failure or whatever reason, doing some outage, so that I don't have to use command override option in UI. And before I want to run some maybe script as I'm doing here, I'm using copy command. So I created my custom script on my local machine, and I'm using the copy directive. I'm saying that I want to copy this file start ssh.sh into the remote location, into the root start ssh.sh within the container. So this will be full path of the script within that container. So this is where it will be actually located. And so copy directive, just copy local files to the container itself. So let me showcase you what the start underscore SSH script actually includes. So you see, like, I'm just printing that I'm starting SSH service, so in case the container image restarted, I want to make always sure that I'm running SSH daemon and I'm running a long running process, so I'm preventing the container instance in Azure to go into the boot loop, right? And now with this, I have specified everything that I want in order to customize my Kali Linux machine. So what I need to do now, I need to build the custom Docker image. And in order to build the custom Docker image, we need to have sudo privileges, all right? So administrator privileges. So that we need sudo command docker build -t. We are putting the name of the Docker image that will be locally available. With dot, we are specifying that where the Docker file is actually located, so in current directory. There is no cache. I don't want to use any like attributes, or I don't want to use any cached information in case I ran previously the Docker build. I want to make sure that I'm evaluating all the options specified in Docker file. And yeah, with this I can just run the command, and it will take some time depending on the all customizations that is required. So it will download the Docker image from Docker Hub. It will update the software repository, install software that I specify, change Kali and the root user's credentials, copy the script there, and will start SSH service and long running process. And after those things are set up, the custom Kali Linux image will be prepared. So what I can do, I can then log in to the Azure container registry that we have previously created, right? With Docker login and fqdn of Azure container registry. As a username and password, you can copy from access keys from Azure Web UI portal. And then with using docker tag command, we are going to basically rename the locally available custom Docker image that we built, right? Kali Linux 003. And we are going to rename it as Kali Linux Kali rolling image into the path of Azure Container Registry server. And then we use Docker push the login server details of our Azure Container Registry, and the full path where it will be located. And this will get uploaded our custom Docker image into the Azure ACR, right? So if we go now to the Azure Container Registry repositories, we will see listed our custom uploaded Kali Linux Docker image. And now what we can do, we can create the container instance in Azure, either from CLI or from the Web UI. For simplicity, I'm using Web UI. I'll fill in the container name region, and I'm going to specify that this time I'm installing Kali Linux container instance from local Azure Container Registry, and you will see that image name will be pulled automatically from this repository because it's locally available, so I can see list of all Docker images, and I can make all other customization and essentially create the Kali Linux container instance in Azure, make sure it's up and running, and then I can SSH to it using either fully qualified domain name or public IP address. And this basically concludes the last section of this demonstration. Now for quick summary, let's recap what we did. So in order to this time we actually install Kali Linux Docker image from Azure Container Instance. So we created Azure Container registry, and we have filled in the details such as resource group, registry name, location, and that's pretty much it. We have noted down or enabled admin credentials so that we can remotely log into this Azure Container registry. We have created custom Docker file that will be built or that will be used to build the custom Kali Linux Docker image. And then we have just basically created also the script that will include the long-running process. We'll build custom Docker image. We have logged into the Azure Container Registry. We have renamed the local custom Docker image into the new name, how it will be called in Azure Container Registry, and then we have uploaded this image into the Azure. And that's it for creation of Azure Container Registry, and then we have created the new Kali Linux Docker instance in Azure. And that's it. So this concludes today's tutorial, and see you next time.